Jigsaw puzzles often have pieces that are arranged in a rectangular grid of rows and columns, where every cell in the grid represents one piece. The grid has two types of pieces: edge pieces which form the outer edge of the grid, and middle pieces which form the inside of the grid. In the example shown, there are 7 rows and 8 columns, and the middle pieces are shaded. How many pieces in total does a 12 by 15 grid have? Okay, so 12 by 15, that's pretty straightforward. It'll just be 12 times 15, which is 180. That's how many pieces, total pieces. How many middle pieces does a grid have? With 6 rows and 4 columns. So if you have a 6 rows and 4 columns, let's just draw. It's something like this. So this will be 6, this will be 4. Now, the outside pieces, or the edge pieces, make up 1. So you have to subtract 1 from both ends. So this would be 4 times 2, right? And 4 times 2, that would basically represent the number of middle pieces, and that is 8. If a grid has 14 middle pieces, then it either has S edge pieces or T edge pieces. Determine the value of S and T. So if it has 14 middle pieces, let's say it looks something like this, and then these are the middle pieces right here, like that. Well, 14, so how did we get 14? It could be 2 times 7, right? 2 times 7. And is there any other way of getting 14? Yeah, I guess you could do 14 times 1. So the first example, this is 7, this is 2. And then therefore this would be 9 and 4. And what are they asking for? Edge pieces. Edge pieces. So edge pieces would mean this would be 9. This would be 9. And then this part here, that would be, I think, 2. And this would be 2 also. So it would be 9 plus 9 plus 2 plus 2, which is 22. All right. So then now we turn our attention to the 14 times 1 scenario. So that's a little bit narrower. Let's see. It's something like this, I think. Yeah. And then therefore this will be 1 and this will be 14. So then therefore that's 16, that's 3. So very similarly, that row would be 16. That row would be 16, and these little guys give 1 each. So it'd be 16 plus 16 plus 1 plus 1, and that would be 34. So I guess S is, you can designate it as 22, and 34 you can designate as the T. A grid with 5 rows and C columns has the same number of edge pieces as middle pieces. Determine the value of C. So we have a scenario. I don't know what it looks like, but I'll just draw the standard shape. It's 5 rows and C columns. So this will be 5 and this will be C. So this from here to here will be 3, and from here to here, that would be C minus 2, right? And they're saying that it has the same number of edge pieces as middle pieces. So the middle pieces, that's just C minus 2 times 3. And then the number of edge pieces, same kind of situation. That's C, and this I believe is 3 and 3. So C and C, so 2C, and then 3 and 3 is 6. So I believe that's the algebra. So now let's solve that. So this will be 3C minus 6 is 2C plus 6. So C is equal to 12. In an ing sequence, the first term is a positive integer, and each term after the first is determined the following way. If a term x is odd, the next term is x plus 3. Term x is even, the next term is x plus 4. For example, if the first term in an ing sequence is 13, the second term is 16, and the third term is 20. If the first term is 7, what is the fifth term? All right, so 1, 2, 3, 4, 5. So the first term is 7. Now 7 is odd, so the next term will be x plus 3, so that would be 10. 10 is even, so the next term will be that plus 4, so that's 14. That's even, so 18, and that's even, so 22. So 22 is the fifth term. If the fifth term in an ing sequence is 62, what are the two possibilities for the first term? Okay, so 62. Now, in order to get 62, oh, okay, so we're going backwards here. Oh, okay, I got it. Well, this could be a 58, right? Yeah, if it was 59, then that would be odd, and then you would have to get a 62. So let's work with this. 58, then that means that would have been a 54. But there's no way to get 59. There's no way to become odd. Because if it was 56, you would add 3, but 56 is even. And if it was 55, that's odd, and you would go up to 58. So this is not possible. So I guess the only thing that's possible is the 58. This would be 50. And then the first term could be 46, but it could also be 47. Yeah, so you just have to kind of really understand those 2 points, and that'll allow you to get 46 and 47 as the first term. If the first term in an ing sequence is 49, determine the terms appearing in the sequence whose values are greater than 318 and less than 330. Okay, so we're going to have a lot of, we're going to go down the ladder here. So the first term is 49, and then that's odd, so you add 3, 52. And then that's even, so you add 4, so 56. And that's even, so you add 4, 60. And then you just keep on going. So you're just adding 4s, and then eventually, if you keep adding 4, multiples of 4 will happen. Keep adding multiples of 4, I should say. Eventually, you're going to get a 316, 320, 324, and so on, 328, and then 332, and that kind of scenario. So what are the ones between 318 and 330? These 3. Those are the ones that they are asking for. So 320, 324, and 328. And finally, the number 18 appears somewhere in an ing sequence after the first term if the first term is a positive integer n. Determine all possible values of n. Okay, so all right, again, I have no idea where this is going to end up, but somehow there's an 18 in there. And what are we doing here? We're trying to find the first term, which is n, right? Okay, so I guess we got to go backwards. Okay, so let's start. If it's 18, you could have a 15. And if it's 18, you could have a 14, I believe. So let's keep a tally here of our n's, 15, 14. Now that's if the sequence only had 2 terms. Now you could keep going here. Yeah, you could keep going. So let's do the 18, 15. If you had 3 terms, what would happen? I think that you get stuck there because you cannot get a 15. You cannot become odd in this type of sequence. And I think in the previous questions I explained why. Okay, so that doesn't give me anything. But what if you had 18 and 14 and you had 3 terms? You can definitely go from 10 to 14. Yeah. So 10. And then you can also go to 11 to 14. Because 11 is odd and you'd add 3. Okay. So that is good. And now let's go if we had 4 terms. So 18, 14, and 10. The 18, 14, 11 I can't do because I can't become an 11. But I could do this. So this would be 6 or 7, I believe, right? So 7 and 6. And then the 7 one gives us a dead end. But we could continue with the 6. And that would be, I believe, either a 4 or a 3. Oh, wait, hold on. 2 or a 3. 2 or a 3, that's what I meant to say. 3, 2. So there you go. Those are the 1, 2, 3, 4, 5, 6, 7, 8 values for n according to that question. The shaded triangle shown is bound by the x-axis y equals x line and x equals a. If the area is 32, what is the value of A? So the area of a triangle is 1/2 base times height. So the base looks like A. The height to me looks like Y, but Y is equal to X. And X is equal to A. So there you go. And they told me it's 32. So this becomes A squared over 2. So A squared is 64. And therefore A is equal to 8. A triangle bound by the x-axis and the line y equals 2x and the line x equals 10. Diego draws the vertical line x equals 4. The line divides the original triangle into a trapezoid which is shaded and a new unshaded triangle as shown. What is the area of the shaded trapezoid? Okay, so the area of a trapezoid is, you take this side, which is going to be, this y coordinate is going to be 8, right? Because that line is y equals 2x, so 8. And then you take this side, the length I should say, and that y coordinate, x is 10, so y is 20. So add that, and then divide by 2. And don't forget to multiply by the length of the base, which is 10 minus 4, which is 6. So squeeze that 6 in there. And that's it. So 8 plus 20 is 24. So 28 divided by 2 is 14. And 14 times 6 is 84. A triangle bound by the x-axis and line y equals 3x and line x equals 21. Alicia draws the vertical line x equals c. C is between 0 and 21. The line divides the original triangle into trapezoid and new triangle. If the area of the trapezoid is 8 times the area of the new triangle, determine the value of C. Okay, I'm going to need some space here, so let me just, well, I think I can do it here. Okay, should be good enough. All right, so let's first draw the diagram, I should say. And then, so we got our line, that's y equals 3x. And then we have x, what is it? X equals 21. Okay, so that's 21 on the x-axis. And then we have another line, x equals c. Okay, so I have no idea, so I'm just going to put it there. Okay. And then they're saying that this area here is, what is it? 8 times the area of the new triangle. So let's label this. So that trapezoid I'll call 8A. And this triangle I'll call A. And what I'm referring to is the area, of course, because that's what the question says. Trapezoid is 8 times the area of the new triangle. Okay, I think we can do this. So this is C here, so that would be 3C in the y-axis. This is 21 here, so this would be 21 times 363. So those are the y coordinates. And now let's figure this out here. So 8A and A. So A is 1/2 base times height. So 1/2 base is C, and the height is 3C. So that's 3 over 2C squared. Correct? Yeah. And if we were to multiply this both sides by 8, this would be 24 over 2C squared, which I believe is 12C squared. Yeah. I think. Yeah, that should be correct. Okay, and then now let's take a look at this trapezoid and figure out what it would be in terms of a formula. Okay, so first you take that side, and that's going to be 3C, right? Yeah, 3C. And then you take this side, that is 63, so plus 63, and then divide by 2, and then don't forget to multiply by that, so that's 21 minus C, I believe. So 21 minus C. Okay, so 8A equals this, and 8A equals this, so we set them equal to each other. And that will help us solve for C, I believe. So we got 3C plus 63 all over 2 times 21 minus C. And over here, we got 24 over 2C squared, right? Okay, so get rid of the halves, and then that's just going to be 3C plus 63 times 21 minus C, and this will just be 24C squared. And let's do this algebra here. So this will be 63C minus 3C squared plus 1323 minus 63c, 24c squared. And then let's put everything on one side, and so that'll be 27c squared. And I think this just leaves us with 1323. And when you divide through here, you get c squared equal to 49, and therefore c is 7. A triangle is bound by the x-axis and line y equals 4x and the line x equals 1. Ahmed draws his first vertical line at x equals p. P is between 0 and 1. This line divides the area of the original triangle in half. Ahmed then draws a second vertical line at the line x equals q, where q is between 0 and p. This line divides the area of the triangle bounded by the x-axis and line y equals x and line x equals p in half. Ahmed continues this process of drawing vertical lines at decreasing values of x so that each such line divides the area of the previous triangle in half. If the 12th vertical line that he draws is x equal to k, determine the value of k. So let's just do the first two, and then we'll hopefully get an understanding of what's going on. So what is it? Y equals 4x, so it's a little bit steeper there. And then we've got that, and then we got x equals 1. So this is 1. This line is y equals 4x. Okay. All right, so that, then we first draw the line x equals p, and I don't know where p is, so I'm just going to put it, I'm not sure, to be honest, but it doesn't really matter. And, you know, it's not going to be drawn perfectly to scale, but you guys get an understanding. Okay, so we've done that. Now this line divides that original triangle in half. So what that means is that if this trapezoid has an area of A, that triangle would have an area of A. Okay? And that's pretty much all they're doing there. And then what they do is they, let's just see here. Let's do a little bit of calculation first. 2a would therefore be 1/2 base times height. The base is 1, and the height would be 4, right? Because if you go there, that would be 4 because y is equal to 4x. So that means 2a is equal to 2, therefore a is equal to 1. The area. I'm not sure if that helps or anything, but I just, for some reason, I wanted to do that. Okay, we took care of p. Now let's go to q, this guy. So what they're saying is then they do this again, and this time it's going to be a little bit different, or it's pretty much the same thing. I'm just drawing it again because I don't want to make the diagram too messy. So you're just taking this A guy, just this triangle this time, just this one, just that one. So that's what this represents. It's A, and this would be P. Got it? And then what they do now is they draw another line Q. So wherever Q is, that's Q. And they're saying that then cuts it in half again. So therefore this is A over 2, and this is A over 2, like that. Got it? So now if we do the area of this whole thing is A over 2 plus A over 2, which is just A, and it's 1/2 base times height. The base looks like P, and the height would be 4P. 4P. So that means A we had, oh, okay, that is useful to know the value of A. 4P squared. Did I do this right? So that means P squared would equal 1/2, and therefore P would be the square root of 1/2. Okay. All right. Okay. And then we got to do this 12 times, right? So let's just make a table here. The first time, the letter we calculated was P, right? The first vertical line, right? The first was P. The second one was Q. Okay? And then the third, and then fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, and 12th. All right. So did we calculate these already? Well, P we got to be the square root of 1/2. Okay, so that's all we got so far. And then I guess we have to do this again for Q, and let's just see if we get some sort of a pattern, because obviously we're not going to do all 12. So then to get Q, we would have to, use that triangle. So that means that 1/2 a over 2 is equal to 1/2 base, which is q, and then the height would be q times 4, because the line is y equals 4x, so 4q. So that would mean a is equal to 4q squared. A is 1, that's 4. So q would be the square root of 1/4. Yeah. I just like to leave it like that. I don't want to write a half because I think there's a pattern here. I already think I know what it is, but let me just do one more. Let's just say there's one more here, r. So let's just draw that diagram again. Remember, we're just taking this guy here now, where this is q. Same story, we're going to put an r in here. This will be, again, half of a over 2, so it will be a over 4, right? Yeah, and then this will be a over 4. And then this will be 4r. 4q. And this would be 4r. So, again, a over 4 would be 1/2 base times height would be r times r over 4r, I should say. Yeah, 4r. And then this would be 1 over 4 is 2r squared. So r squared would be 1 over 8. And then r would be the square root of 1 over 8. Okay, got it. So I got the pattern. I'm pretty confident this is going to be 1 over 16 square root. And then you guys get the idea. So 1 over 32 square root. 1 over 64 square root. 1 over, 128 square root. 1 over 256 root, 1 over 512, 1 over 1024, 1 over 2048, and then the last one would be 1 over 4096. And you're just multiplying by 2 every time. And this one actually is 1 over 64 if you were to calculate it. And there you go. That is the answer to the question. When people gather for a meeting, each person shakes hands with all, some or none, or the other people, and will never with the same person twice. When a handshake occurs between two people, that is counted as one handshake. After a meeting of 5 people, Amrita shook hands with exactly one person. Bin and Carlos each shook hands with exactly 2 people. Dennis shook hands with exactly 3 people, and Elois did not shake hands with anyone. How many handshakes took place? Okay, so let's make a list here. We got A, B, C, D, and E to represent the 5 people, and the number of handshakes, 1, 2, 2, 3, and 0, right? Okay, so let's make a little bit of a diagram here. So we have A, we have B, we have C, and we have D, and then Eloise, she doesn't shake hands with anybody, so I put her far away, so she's not included. And I'll draw lines to represent handshakes. So A is only shaking one hand, so let's just say that that one handshake is with D. Now D has 3 handshakes, so D has to be connected to A, B, and C. So let's draw that. And then B and C only have 2. So they already have 1 coming out, so the next one must be with each other. Now, it might take you a little bit of trial and error to get that kind of a diagram, but that's pretty much the diagram. It represents basically what this is saying. Now they're saying what are the total number of handshakes. Total number of handshakes is represented by the total number of lines. So it'd be 1, 2, 3, 4. 4 handshakes. Yeah. I think that's it. 4 handshakes. Or what you could do is you add up what the information they gave you, 1, 2, 2, and 3 adds to 8. And then since each of those represents 2 people, you divide by 2 in order to get sort of the unique number of handshakes Yeah. So this is a very important line here. When a handshake occurs between two people, this is counted as one handshake. So the unique number is 4. So either way, I got the same answer. At a meeting of 9 people, each participant said that they shook hands with exactly 3 people. Explain why this is not possible. Okay. So we have 9 people this time, and each person has 3 handshakes. So the total handshakes is 3 times 9. But remember, we have to divide, which is 27, but we have to divide by 2 to get the number of unique handshakes, and that's 13.5. But that can't be possible because the number of unique handshakes has to be an integer. So you can just write that. At a meeting of 7 people, at least one handshake occurred within each group of 3 people. Determine the minimum possible number of handshakes, m, that took place at this meeting. A complete solution must include the value of m, an explanation of why the given conditions can be satisfied with some specific set of m handshakes, and an explanation of why fewer than m handshakes does not satisfy the given conditions. All right. Okay, so what do we do here? 7 people, right? Okay, so 7 people. Let's just give them letters here. A, B, C, D, E, F, G. So these are the 7 people. And at least one handshake occurred within each group of 3 people. Okay. Interesting. And determine the minimum number of possible handshakes. Okay. So very similar to before, we're going to create some sort of a diagram that represents this scenario, and then I'll try to explain why this is going to work. So there's the 7 people, and I'm going to make them have handshakes like this. So each line represents the number of handshakes. Okay, so now this is a diagram that is going to attempt to explain why this is the scenario. So first of all, let's count the number of sticks. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 handshakes, so therefore m is equal to 9. Now we just got that, the value of m, but we have to explain why. Okay, so why does this work? Well, read the question. It says that if you take any group of 3, it will satisfy the condition that at least one handshake occurred. So let's take a group of 3. Let's take person A, and then 2 more people, and let's see if it satisfies the condition, which is at least one handshake within each group of 3 people. So this group. Now, whatever we put here, if we put, for example, B and we put C, well, obviously, because they're all part of the same sort of group, any 3 from that group, A, B, C, and D, will satisfy it. I hope you can see that. There's always going to be at least one handshake between any 3 of that group of 4. So what we need to do is show what happens if we have, let's say, so if you have any combination with the second guy you chose as B, C, or D, and the third guy you chose was B, C, or D, this condition is satisfied. Now let's say you have second guy you chose is anything from B, C, and D, but the third guy you chose is from this group, E, F, or G. Will that work? Well, yes, because A connects with any of the B, C, or D guys. Even though there's no connection between this group and this group, that doesn't matter because we only need one handshake, so that satisfies it also. What if we have EFG as the second guy and then EFG again? Somebody from EFG. Well, anybody in EFG connects with any other in EFG. So that will satisfy also. So the only way that this would not work, with this diagram it always works, but the only way it would not work is if you had completely separated them in three groups. So A, B, and C, D, E, and F. And then you put the seventh guy out there. And then you chose A, D, and G as a group of three. You'll notice that it would fail. It would not satisfy the equation, because A does not shake hands with D and D does not shake hands with G. But this is not the diagram we created. We created this diagram here, and that one satisfies all the conditions. And then finally, I guess we have to talk about if M is less than 9. Well, in this case, it's less than 9, right? Because count the number of handshakes here. We have 1, 2, 3, 4, 5, 6. So this is a scenario where M is less than 9 in particular. Oh, sorry, M is less than 9, where M is equal to 6. And as you can see, if you chose A, D, and G, it would not satisfy the condition. So I think that's pretty decent explanation of this question.